So this video talks about life expectancy in terms of descriptive statistics. So we're first going to just talk about this graph and what it means and talk about some data. And then we're going to actually talk about calculating life expectancy, and then, mean, median, that kind of thing. So you see this, and we've got at birth, so this first one is birth, then we get to age 20, so the second one is age 20. Then we have life expectancy at age 40, and then the last one up here is age 60. So you can see that this is in the U.S. Over years. So you might want to come back and reference this, maybe take a picture so you have it if you don't have your packet with you, but this is what I'm going to use to reference. So let's look at 1 and 2 kind of together. We're going to look life expectancy at birth in 1900 and then in 1998. So here the key is at birth. So, oops, wrong way. So at birth, here is at birth in 1900. Here is at birth in 1998. So we could say this one is approximately 47. So that means in 1900, when you were born, you could expect to live to be around 47. In 1998, when you were born, if you look across, it's pretty close to 75. Let's call it 75. So in 1998, when you were born, you could expect to live to be approximately 75. So 40. Why can't I write here? 47 and then 75. So number 3, has life expectancy changed much for individuals at age 60? Wow, well, okay, let's go back and look. So age 60 is the top one. So here it was like at 75, and here it might be at 80. So for 60, we went from 75 maybe to 80. Is that a big change? Yeah, not really. And that means, at age 60, that means if you live to be 60, your life expectancy is now 75 in 1900 or 80. So think about it. In 1900, if you lived to be 60, you could then expect to live 15 more years. I mean, that's kind of crazy for 1900. In my mind, everybody died young then, but that is not the case. All right, let's look at number 4. What was the life expectancy for a 20-year-old in 1900? And for the most current availability here. So now we're looking at the 20-year-olds. So let's get rid of this. Let's go to the 20s. So here, I would say that's about 62, maybe. And then it goes up to about here, which is, I don't know, maybe 76. And again, I'm estimating, right? These are not perfect. But when we're talking about 20-year-old, we're talking about 62 to 76. That leads us to number 5. Why was life expectancy at age 20 so much higher than life expectancy at birth? Remember, at birth, it was roughly 47, and at 20, meaning if you made it to age 20, you could expect to live to be 62. So why is it that if you made it to 20, you could expect to live longer than those who, than when just at birth? And if you think about it, in 1900, what kind of medical care did we have? Definitely not what we have now, right? We didn't have, I don't want to say better nutrition because we have a lot of crap in our food now, but we have, just life in general is so much different, right? There's a hospital in every corner now. You need help, you call 911, they're there in 2 minutes. Back then, if you lived out in the boonies, right, you called the horses and you were hoping that they could help you, right? So just things have changed. And number 6, is the difference in life expectancy between birth and age 20 any different now? Now, if we look at 1998, right, because that's our most recent, at age 60 we're at about 80, and at 20 we're at about 76 is what we said. So, birth. I did 60, my bad. Birth is like 75. So, no, if you're looking at birth to age 20, we're talking about 75 to 76. Now, when you have a child, they can expect to live as soon as they are born as they would if they could make it to 20. So the difference is the advances in medical technology, right? That's probably got the most to do with it. All right, so enough about looking at the table. Let's play with some data. So when we calculate life expectancy, we are finding the mean of the ages at death. And I know that sounds morbid, and it really is, but that's what it is. So to find the mean, right, we add them up. You add up all the numbers, and you divide by how many numbers you had. So that's what we're going to do. We're going to start by saying, here it's very sad, but these are the ages of 10 people when they died. Okay, so just 10 random people, the ages when they died. We can calculate the mean, the average, or the mean age at death. And if it's everybody, if it includes everybody, we didn't put a limit on how old they had to be, this is life expectancy at birth. So to calculate the mean, we're going to add all of these numbers together. And when we do that, we should get 377. And because there are 10 of them, we divide by 10. And so we would say, based off this data, you can, at birth, so when you have a child, they would expect to live to be 37.7. Now, you can see, obviously you can live to be much older than 37.7, but you also could only live to be 4, which is very, very sad. So that's why this is the average. When you look at all the ages at death, that is how we calculate life expectancy. Now, when you talk about life expectancy at age of 20, well, then you're saying we're only dealing with people who made it to 20. So we would cross out the 3 people who didn't get there, and we are now just looking at these 7 numbers. So we add these 7 people together, and we would get 354, and we would divide by 7, and we would get 50.6. So if at birth, you could expect to live to be 37.7. If you made it to 20, you can now expect to be 50.6. Life expectancy at 40. Well, at 40, we only care about those who made it to 40. So we add these numbers together and get 298. There are only 5 of them, so we divide by 5. And if you make it to 40, you can expect to be 59.6. And then if you want to go to 60, you get rid of only the people who made it to 60. So we add those two, and we take 139 divided by 2. If you make it to 60, you can expect to live to be 69.5. So you can see that's much longer than at birth. Well, it makes sense. You've lived longer, right? So you've got a better chance. All right, so that's the mean. We are going to do the median also before we leave. So the median simply means middle number. And we're going to find the mean and median in more videos. This is not the only one, so bear with me. The big thing about the median is that your numbers have to be in order least to greatest. So these numbers are, right, 4, 7, 12, 22, they're in order least to greatest already. So what we're going to do is we're going to calculate the middle number. And I usually do a cross-out method. And let me show you what that means. I usually say I take off one from the small and one from the big, right? We're working our way to the middle. So I simply cross one out, low to high, low to high. Now you will see I am left with 2 numbers in the middle. If this happens, and this will happen every time you have an even number, I had 10, 10's an even number, I'm going to have 2 numbers in the middle. So my median is actually between them. So to calculate it, I would take 34 plus 46 and divide by 2. 34 plus 46 is 80. 80 divided by 2 is 40. So my median is 40. And that makes sense, right? That's right in the middle. When I do this, you will notice I have 5 numbers on the left. I have 5 numbers on the right. The median should cut your data exactly in half. Now, how does the mean compare to the median? Well, the mean was 37.7. The median was 40. So the mean is less than the median. And we're going to get to be what does all of that mean here in the next video. Now, suppose there was an error. Before the oldest age was 76, they said, oops, it should have been 84, right? We jacked up old Billy's death certificate. So let's recalculate the mean. Well, recall that means we have to add all these together. So once you add them all together, we should have gotten 385. There are 10 dead people. We divide by 10. And our new mean is 38.5, which is slightly larger than what we had before, which makes sense. We had a bigger number. Our mean's going to go up. Now, the median, if you think about it, you're like, Becky, it's not going to change. Well, you're right, it's not. When we get rid of, right, go to the middle, go to the middle, go to the middle, we're left with 2 numbers in the middle. It's the same. Our median is 4. So if you change one of the outer data values, right, the median is always the number in the middle. So if something outside changes, it's not going to affect the median. The median is resistant to extreme measures, right, those big ones on the end, whereas the mean is affected by the slightest change anywhere. And I think that's the end of this video.